question number 5, in which we are computing the dissimilarity between student feedback profile based on different types of attributes: nominal, binary, numeric, and even textual feedback. These concepts are widely used in clustering, data mining, and educational analytics. So let's start with the nominal attribute, which includes things like student's department or the elective they choose. These are simple categories, they are no order or no numeric value. To measure dissimilarity here, we use something called simple matching dissimilarity. Uh, Dissimilarity is 1 when category differs and 0 when the same. For multiple attributes, total dissimilarity is count of proportion of mismatches. So Dij is equals to 0 if category matches 1, if category matches differs. Okay. So it's work like if two students belong to the same category, the dissimilarity is 0, and if they belong to different categories, the dissimilarity is 1. And when there are multiple nominal attributes, we can compute the proportion mismatches. For example, if two students matches 3 categories but differ in 2, the dissimilarity becomes 2 out of 5. This method is simple, intuitive, and works perfectly for pure category based feedback. Moving on to asymmetric binary attributes. So, like whether a student attend a workshop, yes or no. The attributes are asymmetric because a yes carries meaning and while no doesn't. So, for example, two students not attending a workshop does not mean they are similar in any useful way. So, we use Jacquard dissimilarity. D is equals to 1 minus A upon A plus B plus C. So, here A is number of times both student has 1. B plus C cases where one has 1 and another has 0. And matches of 0, 0 are ignored. 0 minus 0 is ignored. So, this method gives more weight to meaningful yes events and avoids misleading matches. Moving on to the numeric attribute. So now let's move to numeric attributes such as CGPA, attendance percentage, or number of completed assignments. For numeric data, the best way to measure dissimilarity is using Euclidean distance, where that we know d is equals to under root of xi of minus yi whole square. So the idea is simple: the greater the numeric difference between two students, the larger the distance, and therefore the higher the dissimilarity. So this method works extremely well when comparing continuous data like marks, performance scores, or attendance percentage. Now moving on to the term frequency vectors. This which come from open text feedback like comments students write about teachers, lab, or classes. To analyze this, we convert each feedback comment into a word frequency vector using TF or TF minus IDF. Once the feedback is turned into vector, we measure dissimilarity using Gaussian dissimilarity. The formula is 1 minus a into b upon mod of a cross mod of b. Here's what that means. First, we compute cosine similarity, which measures the angle between two word vectors. If the angle is small, the student use similar keywords, meaning their feedback is similar. And when we separate it from one to get the dissimilarity. Cosine based dissimilarity is extremely useful because it focuses on pattern of word usage rather than raw counts, make it perfect for text analytics. So let's quick recap the dissimilarity measures for each attribute. Nomical, no, Nominal is simple matching, straightforward comparison of category labels, which is categories, and asymmetric binary. We use measures like Jacquard and Jacquard dissimilarity, which appropriately emphasizes the important present one matches and ignores absent zeros matches. In numerical, the CGPA or the percentages of students we have seen in the numeric, which we use, which the measure we use is the Euclidean or Manhattan distance, which calculates the physical distance between data points in multidimensional space. And to the text, the vector, we use TF or TF IDF cosine dissimilarity, which captures the difference in pattern and relative frequency of what you said. So thank you so much. This is the question number 5 and we have done it. Thank you so much for watching my video. And next question we will be doing question number 6.